Hello, hi. I wiped away my tears from day one, so here we go with day two. So with day two, we're really going to focus on actually still simplifying identities, but we're going to add in a new concept called verifying identities, which that'll come later. But we're going to kind of focus on some day one stuff and kind of just do more practice problems, and then we'll dive into verifying. So starting off, in this top section, I would definitely say pause here for a second and fill in this top section. You want to really see what you remember and fill in as much of this as you can. All right, so let's go through it. So 1 over sine theta is going to be cosecant theta. So remember, don't forget to include your variable. You have to include your variable. If you just write cosecant, that would be wrong, and you would not get any credit. And that concludes the lesson. Just kidding. All right, so for the next one, so 1 over cosine theta, that's going to be secant theta. And then 1 over tangent theta, that's going to give you cotangent theta. 1 over cosecant theta is going to give you sine theta. 1 over secant theta is going to give you cosine theta. And then 1 over cotangent theta, that will give you tangent theta. Ta-da! So those are your reciprocal identities. Now we're going to go through the quotient identities. So with quotient identities, sine over cosine, or sine cosine, nope, sine theta over cosine theta, there we go, is going to give you tangent theta. And then cosine theta over sine theta will give you cotangent theta. Now we're going to look at the Pythagorean identities. So with the Pythagorean identities, so your first major one that we're going to have is going to be sine squared x plus cosine squared x equals 1. Now, just to kind of give you a note, it doesn't necessarily matter which variable you use. If you want to do theta, you can. If you want to do x, you can. You can do any letter, any variable. So if you remember, sine squared x plus cosine squared x equals 1, we call this Big Papa. So with Big Papa, that's where your other identities, your other Pythagorean identities are going to come from. So your next one is going to be tangent squared x plus 1, which is going to equal secant squared x. And then your other identity is going to be 1 plus cotangent squared theta, or x, is going to equal cosecant squared x. So just as a recap, I like to remember that the c's go together, cotangent and cosecant. That's kind of how I remember it. But yeah, in addition to your Pythagorean identities, make sure you also know all variations. That bell is so annoying. All right. So these problems, I'm not gonna lie, this video is probably gonna be pretty lengthy because I want to go through each and every single one of these problems because I just want to give y'all as many different viewpoints and perspectives as possible when it comes to solving these identities. Because I know some of these are going to be kind of straightforward, a little simple, and some of these are going to be the end of the world, it feels like. So, starting off, so I'm going to start by, actually, before we do this, let's kind of talk about what we call the bag of tricks. So the bag of tricks is actually going to be down here under verifying. So this is just all the different ideas and ways in which we're going to simplify these identities. So for example, we have Big Papa here, which means you can use your Pythagorean identities to help solve. So you're going to look for your pairs that can simplify to 1, essentially is what this is saying. So you're also going to want to look at your variations as well. So I will say your Pythagorean identities are going to be extremely important for the go away. So So the next thing is splitting the numerator. So when you split the numerator, that's also going to help with some problems. Perfect square trinomials is not going to be as common as you think, but it does come in here and there. Multiplying by a funky form of 1, this one is going to happen all the time. So that one's going to be pretty important. Let's do this. So this one's going to be pretty important. Factoring is going to happen a good amount of times. Most notably, the type of factoring you're going to want to know is doing your greatest common factors. You also need to make sure that you're good with perfect square trinomials and your difference of squares, which those are from Algebra 1, which are going to be over on the right side. And then another really important idea is rearranging your terms. So when you rearrange, some of those pieces may actually form an identity. So that's also going to be another really important part. So difference of squares, this is going to kind of tie in with factoring. writing your trig values in terms of sine and cosine, this is another really big one. So that's what we're going to probably do the majority of the time. And then getting a common denominator. So this is going to be kind of a funky form of 1. So over here, we have it in terms of conjugates. Over here, this is just getting a common denominator. But either way, a funky form of 1 is going to be a really important idea. And then over here, we also have FOIL, which is another way of doing double distribution. I know FOIL is not technically a mathematical term, it's just kind of an acronym, but the mathematical way of doing it is a double distribution. All right, so kind of knowing all these tricks and all these ideas, now let's kind of get into simplifying. So with this first one up here, what I'm going to do is focus on rewriting everything in terms of sine and cosine first. So secant squared theta, I'm going to change this one into 1 over cosine squared theta, or x. And then I'm going to have sine squared x in the top, and then secant squared theta, I'm going to change that to 1 over cosine, so that's just going to go to the bottom. So sine squared x over cosine squared x. And then now that we have a common denominator, now I'm going to combine these fractions. So this is going to turn into 1 minus sine squared x over cosine squared x. And then in the numerator, 1 minus sine squared x, we know that from Big Papa. So that's going to equal cosine squared x. And then that's going to be over cosine squared x, which when you simplify is just going to equal 1. Number 2. I feel like using green today. Let's use green. All right, now over here, so I'm going to use a Pythagorean identity here. So 1 plus cotangent squared x, that's going to be equal to cosecant squared x. So cosecant squared x over secant squared x. And then I'm going to change these to terms of sine and cosine. So cosecant squared x is the same as 1 over sine squared x. And then secant squared x is the same as 1 over cosine squared x. So we have this beautiful looking fraction over here. So as you hopefully remember, I'm going to just forget what I'm saying. That's perfectly fine. So when you divide by a fraction, you're going to multiply by its reciprocal. So we're going to have 1 over sine squared x, and then we're going to multiply times cosine squared x over 1. So what this leaves us with, when you multiply across in these fractions, that's going to leave us with cosine squared x over sine squared x, and then that's going to give you cotangent squared x. Ta-da! Hopefully you're not crying already. I am. So number 3. So we have 1 over sine x cosine x minus cotangent x. So what I'm going to do here is get everything just in terms of sine and cosine. So I'm going to leave that first term alone. So we have 1 over sine x times cosine x, and then minus cotangent. So cotangent, I'm going to turn this sucker into, hopefully something legible, into cosine x over sine x. So now what I need to happen is I need to get a common denominator so I can actually combine these fractions. So you notice that both fractions, we have sine in the denominator already, but notice how the one on the left, we have cosine x. So that means I need to have cosine x over here on this side. So what I'm going to do is multiply by a funky form of 1. So I'm going to multiply this right term by cosine x over cosine x. So when I do that, we're going to leave that first term alone. So we're going to still have 1 over sine x cosine x. And then I'm going to subtract the numerators. I'm going to multiply. So that's going to be cosine squared x. And then that's going to be over sine x times cosine x. So now that we have a common denominator, now I can combine these fractions. So this is going to leave me with 1 minus cosine squared x over sine x times cosine x. And then in the top here, 1 minus cosine squared x, this is going to be a variation of Big Papa. So 1 over cosine squared x, I'm going to bring this up here. So that's going to turn into sine squared x. And that's going to be over sine x cosine x. And then we have two sines in the top, and then we have one in the bottom. So I'm going to take one from the top and bottom. So when I do that, that's going to leave us with sine x over cosine x, which is going to be equal to tangent x. Ta-da. Number 4. Oh, goody. All right, this is the gross one. Okay, so with number 4, the big idea here is you really just need to get a common denominator. So what I'm going to do is, oh, I got my keys. So what I'm going to do, I'm going to write the original problem in black, and then you'll kind of see what I'm adding on in color. So I'm going to have 1 over secant x minus tangent x. And then what I need to do is I need to get a common denominator. So what's going to happen, first off, just to kind of give you a warning, number 4 is kind of a lot, so I'm probably going to venture and write into number 6 a little bit, or a lot actually, but it's okay. Just keep that in mind. So I need a common denominator. So what I need to do is multiply by a funky form of 1 on both of these values. So I'm going to multiply by secant x plus tangent x for the left term, and then multiply by secant x minus tangent x on the right term. So what's going to happen is now I'm going to multiply the left side by the right-sided denominator. So I'm going to multiply by secant x plus tangent x over secant x plus tangent x. So here's my funky form of 1. And then I still need the original for the second term. So that's going to be 1 over secant x plus tangent x. And then my funky form of 1 over here is going to be the denominator of the left side. So I'm going to multiply by that on the right side. So I'm going to have secant x minus tangent x over secant x minus tangent x. And then this is the monstrosity that I now need to simplify. So if you notice the numerator in both of these, I'm just going to write on the top. So I'm going to have secant x plus tangent x in the top, and then I'm going to have secant x minus tangent x in the top over here. Okay, so when I simplify, nope, I'm going to need a much longer fraction bar than that. So in the numerator here for this term, I'm going to have secant x plus tangent x, and that's going to be over secant x minus tangent x times secant x plus tangent x. And then we're going to add the other term. So once again, we're going to have a common denominator, but in the numerator, we're going to have secant x minus tangent x, and that's going to be over secant x plus tangent x times secant x minus tangent x. All right, so the next step I'm going to do, now that we have a common denominator in both, now I'm going to combine the numerators. So I know there's a bunch of different steps I can do. I can do like multiple steps in one, but with identities, since we're still kind of starting out, I want to do this kind of like one step at a time. So in the top, we're going to have secant x plus tangent x, and then I'm going to add the numerator on the other side. So secant x minus tangent x. Minus tangent. And then that's going to be all over secant x minus tangent x and secant x plus tangent x. Okay, so for this next part, notice how we're going to have a positive tangent x and a negative tangent x. So these are going to be crossed out, or zero out rather. And then in the bottom, what I'm going to go ahead and do is I'm going to go ahead and multiply out the bottom. So I'm going to do, so the tangents in the numerator are going to cross out, so we're going to have 2 secant x, because we have secant x plus secant x. And then that's going to give me secant squared x when I just do the double distribution, then plus secant x tangent x minus secant x tangent x, and then minus tangent squared x. So as y'all can see, this one's absolutely disrespectful. All right, and then what's going to happen here, as you can hopefully see, we have a positive secant tangent x, or secant x tangent x, and a negative secant x tangent x. So those are just going to cross out. So then what's going to happen is we're going to have 2 secant x over secant x minus tangent x, or squared x. And then what's in the bottom here, this is going to be one of your Pythagorean identities. Secant squared, ooh, no, I just made a crucial error. Can y'all guess what I did? Hopefully, I didn't write my variable, minus 50. So secant squared x minus tangent squared x, there we go. Now it's a Pythagorean identity. So what's going to happen is this will be 2 secant x over 1, which is just going to be 2 secant x. Ta-da. Wow, that was awful. All right, so this one was truly abhorrent. So I'm going to shrink you so you can go over there. Excuse me. Alrighty, number 5. So for number 5, once again, we're just going to focus on getting everything written in terms of sine and cosine, and then getting common denominators or multiplying by funky form of ones. Those are going to be your most common tactics. So for this one, so in that first term, I have my sine theta, and then I'm going to rewrite cosecant theta as 1 over sine theta. If I could actually write legibly, that would be phenomenal. All right, and then over here on the right side, we're going to have our cosine theta. And then secant theta, I'm going to rewrite as 1 over cosine theta. Now what's going to happen is I'm going to multiply by the reciprocal since we're dividing these fractions. So this is going to turn into sine theta times sine theta over 1. And then we're going to have cosine theta times cosine theta, not squared, cosine theta over 1. So now I'm going to multiply these since they're technically both numerator values. So when we multiply the numerators together, that's going to give me sine squared theta plus cosine squared theta, which hopefully you remember, this is a Pythagorean identity, this is Big Papa. So that's going to equal 1. Number 6. Please stop crying. I know this is awful, but it's my personal fave. Okie dokie. All right, so let's choose a fun color. I mean, this is also terrible, so what makes it fun? Anyways, so with this one, so now we have sine n plus cosine n times cotangent n. So once again, I'm going to focus on just rewriting everything in terms of sine and cosine. So sine n plus cosine n, and then cotangent I'm going to rewrite as cosine n over sine n. So when I rewrite, I'm going to multiply my numerators together. So this will be sine n plus cosine squared n over sine n. And now I need to get a common denominator. So over here, this is technically over 1, so I need to have a sign down here. So what's going to happen is I'm going to have sine n, and I need to multiply by sine n over sine n, so I can get that common denominator. And then plus, so cosine squared n over sine n. So when I do this, once again, we're going to multiply these numerators. So sine n times sine n, well, that's going to give you sine squared n. Then that's going to be over sine n. And then plus, now we're going to have cosine squared n over sine n. And now that we have a common denominator, now I can add these values together. So the numerators I'm going to combine into 1. Go away. Okay, so we're going to have sine squared n plus cosine squared n, and that's going to be all over sine n. Now in the numerator, sine squared n plus cosine squared n, that's Big Papa, so that's going to be 1 over sine n. So 1 over sine is going to be equal to cosecant n. So there's your answer. Ta-da! All right, moving on. So over here, we have cosine to the fourth of m minus sine to the fourth of m over cosine squared m minus sine squared m. So this may not be as obvious, but hopefully as you do more of these, the trick will be a little bit more obvious. So this, what we're going to do here is we're going to do a difference of squares. So that's a squared minus b squared, which is going to equal a plus b, and then a minus b. So that's what we're going to do down here. Okay, so when I take the square root to find that term, remember this is going to be cosine m to the fourth, and then the square root is the same as just doing the 1/2 power. So when I do the difference of squares, it's going to be all the values squared. So if you're still like, what the heck does that mean? That's okay. So essentially, we're just going to cut these powers in half when we do the difference of squares. So what that's going to leave us with, I'm going to need a longer fraction bar. Here's my obnoxiously long fraction bar. So this is going to be cosine squared m plus sine squared m. And then I need cosine squared m, the same thing, but now minus sine squared m. Okay, and then that's going to be all over cosine squared m minus sine squared m. So notice how the values in parentheses, this all represents a single value. So we've got cosine squared m minus sine squared m in both the top and the bottom. So those are going to simplify and cross out. So what we're left with is just going to be cosine squared m plus sine squared m, which that's going to be Big Papa, which is just 1. Ta-da! All right, number 8. So with number 8 over here, let's switch to a lighter green. So I see cosine squared w minus 2 cosine w plus 1 over cosine w minus 1. So when I see this, I kind of picture like x equals cosine of w. So to me, this is actually going to turn into x squared minus 2x plus 1, which this can factor. Now, if you kind of see it, this is actually what we call a perfect square trinomial, meaning I can take the square root of the first and the last and then take the sine of the b term. And then what this is going to equal is x minus 1 squared. So it's a perfect square trinomial. So we're going to relate that information down here. So when I do this, when I do the perfect square trinomial, that's what I just did over here. So I'm just going to write in the x value, which is going to be cosine. So we're looking at cosine w minus 1 squared over cosine w minus 1. So we have 2 of those in the top and only 1 of them in the bottom. So I'm going to take 1 away from both, which means we are left with cosine w minus 1. So that would be your final answer here. So now that we kind of did some practice from day 1, now we're going to move into verifying identities, which, like we talked about before, we're going to use this bag of tricks to kind of help. But we're going to kind of add on to it a little bit. So with verifying, you're going to work with that bag of tricks by rewriting only a single side of the equation. This is super important. You do not manipulate both sides, only a single side. That is crucial. If you're manipulating both sides, then you're just doing the most, because no. So it does not matter whether you choose the left-hand side or the right-hand side, so that's what this part down here is saying. I just recommend that you choose the side that looks more complicated. So look for the dumpster fire, essentially. Look for the one that looks like an abhorrent mess. That's what you want, ironically. So emphasis, or not emphasis, but just a note, if you ever see RHS, that just means right-hand side, and if you ever see LHS, that just means left-hand side. So we may abbreviate those, but just keep in mind that whenever you see those, that's just referring to a different side. All right, number 9. So now we're going to verify. So we want to either turn the left side into the right side, or we want to turn the right side into the left side. So remember, you want to only manipulate one side. Do not touch both. So essentially, think of it like a proof. So in my eyes, it's all a dumpster fire, but the left-hand side looks slightly more dumpster fire-ish. So we're going to go with the left side. So I'm not going to touch this side at all. Well, not cross it out. I'm just not going to touch it. No touchy. As Finding Nemo is. No touchy. So on the left side, I see this sine squared theta, and I'm going to do Pythagorean identities. So I'm going to change that to 1 minus cosine squared theta. So 1 plus sine theta minus, and then I'm going to change this to 1 minus cosine squared theta. And then that's going to be over cosine theta. And then when you're writing or verifying, you're not going to write anything on the left side. You're going to leave it blank because you're not manipulating the right side. You just want to manipulate the left side. So I'm going to leave it alone. So you do have to make sure you include your equal sign since we're verifying. So the next step, I'm going to distribute this negative. So right here, I'm going to take this negative and then distribute. So we're going to have 1 plus sine theta minus 1, then plus cosine squared theta. And then that's going to be over cosine theta. Don't forget your equal sign. And then what I see is we have a positive 1 and a negative 1. So those are going to simplify and zero out. So that's going to leave us with sine theta plus cosine theta, or cosine squared theta, all over cosine theta. Equals. There. So yes, it's simplified, but it still doesn't look like the right side. So I still need to keep going. So now what I'm going to do, I also notice I have 2 terms on the right side. I only technically have 1 over here. So I'm going to split the numerator. That's kind of my indicator there. So I'm going to rewrite it as sine theta over cosine theta, and then cosine squared theta over cosine theta. So those are going to get their own fractions. So we're going to have sine theta over cosine theta, and then plus cosine squared theta over cosine theta. And that's my time. Just kidding. Go ahead, keep going. So sine theta over cosine theta, that's going to give you tangent theta. Then plus, we're going to have cosine squared theta over cosine. That's going to just give you cosine theta. So, and that equals the right side pretty much. It's just not in the right order, so I guess I'll do it in the technical sense. So I'll go ahead and switch it. So cosine theta plus tangent theta, just so that it exactly matches the right side. And then when you're done, when it matches, put a check. So quick little note, because people in the past have tried to get away with this. I mean, you can try, but I can almost guarantee you will not succeed. People have tried to write just utter and complete garbage until they get to the very end, and then they just write what the right answer is supposed to be. Because we give you the answer. So people have written complete and utter nonsense, and then they'll just write what it's supposed to be at the end. Well, here's a little note for you. Each step is going to be worth a certain amount of points. So if you're just writing the last step here, this isn't really worth anything because we give you the answer. So we're looking at the work. This is where the points are going to come from. So if you're writing nonsense here and you just write the answer, you're not going to get any points. So just keep that in mind. All right, number 10. So number 10 is going to be really similar to number 7 up here, where we're going to do the difference of squares. So over here, the dumpster fire I see is going to be the left-hand side. The right-hand side is also a dumpster fire, but you know what? This side is more ferocious. So when I do my difference of squares, so this is going to turn into cosine squared h plus sine squared h. And then we're going to have cosine squared h minus sine squared h. So So I'm not manipulating the right side, so I'm going to leave it blank over there. And then what you hopefully notice right here, cosine squared h plus sine squared h, that's Big Papa. So that's just going to go to 1. And then we're going to be left with cosine squared h minus sine squared h. And, well, that matches. So I'm just going to get rid of that 1. We'll not get rid of it, just write a new line. So we have cosine squared h minus sine squared h. And that is equal to the right-hand side, so we are good. Check. Checkity check. Moving on. Oh, lordy. All right. These are going to be fun. So moving on to 11. So I am going to do all of these, so no goody. So cosecant r plus cotangent r times 1 minus cosine r, and we want to prove that it's going to equal to sine r. Okay, so I'm going to change everything to sine and cosine first. So cosecant of r is 1 over sine r, and then plus cotangent r is going to be cosine r over sine r, and then that's going to be 1 minus cosine r. So the left-hand side is the obvious dumpster fire, so that's the side I'm going to manipulate. All right, and then on the left term over here, we already have common denominators, so I'm going to go ahead and add those fractions. So that's going to be 1 plus cosine r over sine r. And then we're going to have multiplied times 1 minus cosine r. So these are both numerator values, so I'm going to multiply those out. So when I multiply them out, it's going to be a double distribution, however you want to write it out. Come on. So this is going to be 1 minus cosine r plus cosine r, and then minus cosine squared r, all over sine r. So what's going to happen is I'm going to extend this because that's going to bother me. So in the middle here, your negative cosine and your positive cosine, those are going to zero out. So we're going to have 1 minus cosine squared r over sine r. And then 1 minus cosine squared r, this is a variation of Big Papa, which is going to equal sine squared r. So we have sine squared r over sine r, which is going to just simplify to sine r, which doesn't match the right side. Yes, it does. So check. Number 12. I'm so tired. Okay, number 12. So this is a good example of it's not going to matter which side you do. Both sides are going to be complete and utter dumpster fires. So it's not going to matter whether you do the left side or the right side. But which side do I want to do? Well, I see the fraction, or not the fraction. I see multiple terms in the denominator over here. So for me, what I want to do is I want to multiply by the conjugate. That's going to kind of help me get in a better place. So I'm going to do the left side. So we're going to have sine theta over 1 plus cosine theta. And then for the conjugate, I'm going to multiply by 1 minus cosine theta. Okay, and then once again, you're going to leave that right side just as an equal sign. You're going to leave it alone. So now I'm going to kind of simplify. So in the top, I'm going to just leave it as sine theta, and then 1 minus cosine theta. And in the bottom, over here where we have the 1 plus cosine and the 1 minus cosine, I'm going to multiply those out. So that's going to be 1 minus cosine theta plus cosine theta. And then that's going to be minus, oops, there we go. So 1 minus cosine theta plus cosine theta minus cosine squared theta. There we go. Okay, so we're going to be left with sine theta, 1 minus cosine theta, and then over 1 minus cosine squared theta. Ooh, this is what being a lefty gets, y'all. I'm starting to write crooked. Close enough. Okay, now I see a variation of Big Papa in the bottom. So 1 minus cosine squared theta is going to be equal to sine squared theta. So I'm going to leave the top alone. So sine theta times 1 minus cosine theta. And then this is going to be rewritten as sine squared theta. Once again, leave the right side alone. And then I'm going to simplify sine theta over sine squared theta. So the sine in the top is going to disappear, but we still have a sine in the bottom. So this will turn into 1 minus cosine theta over sine theta. Which, does that match the other side? Yes, it does. Ta-da! Is anyone crying yet? Hopefully not. I am. Lucky number 13. Woo! Oh, this is a dumpster fire. Okay. 1 plus cosine theta over sine theta plus sine theta over 1 plus cosine theta equals 2 cosecant theta. Okay. So I see my two fractions here. My eyes go directly to the denominators. I need to be able to combine these fractions, which means I need a common denominator. So I'm going to do 1 plus cosine theta over sine theta. So I need to multiply by a funky form of 1 using the denominator from the right side. So I'm going to multiply by 1 plus cosine theta over 1 plus cosine theta. So this is my funky form of 1. And then I'm going to add, so the original second term, so sine theta over 1 plus cosine theta. Why can I not write cosine? And then my funky form of 1 over here, I'm going to use the denominator for the first term. So I need to multiply by sine theta over sine theta. Equals. So we want to manipulate our equation to look like 2 cosecant theta. So this hot boo-boo mess over here is what we need to work with. All right, so I see that we have the same term here. So I'm going to rewrite this as 1 plus cosine theta squared for right now. I'll probably have to expand it. Actually, yeah, I'm going to have to expand that, so there's no point in doing that. So I'm going to leave it as 1 plus cosine theta, 1 plus cosine theta. And then that's going to be over sine theta times 1 plus cosine theta. And I'm going to go ahead and add the other side. So I'm going to extend this. So plus, and that will be sine squared theta. Ooh, lordy. So in the top, I'm now going to multiply this part out because I really can't do much. So when I multiply that left side out, so that's going to give me 1 plus 2 cosine theta plus cosine squared theta. So I went ahead and multiplied it out. And then plus sine squared theta, and then that's going to be over sine theta, and then 1 plus cosine theta. All right, and then I look at my fraction here, and I see I have cosine squared theta plus sine squared theta. That's Big Papa. So this is going to just turn into 1 plus 2 cosine theta plus 1. And then that's going to be over sine theta, then times 1 plus cosine theta. And then I'm going to add my 1's together, so we're going to have 2 plus 2 cosine theta over sine theta, 1 plus cosine theta, parenthesis equals. That's a terrible equal sign. Oh, lordy. Okay, then I'm going to do my GCF. I'm going to take out a 2. So we have 2 parentheses 1 plus cosine theta. And that's going to be over sine theta times 1 plus cosine theta. we're going to actually move you up here. So we're just going to continue it up here. So if you ever run out of space, this is what I would recommend doing. All right, and then you look at your equation so far, and I have a 1 plus cosine in the top and in the bottom, so those are going to simplify. So I'm left with 2 over sine theta, which I'm going to kind of separate this a little bit. So that's 2 times 1 over sine theta, which 1 over sine theta is the same as cosecant theta. So we get 2 cosecant theta equals 2 cosecant theta. So we are good. That one's kind of a lot, but it was okay. Actually, it was a train wreck, and I'm exhausted. 14. So we have secant x plus tangent x equals cosine x over 1 minus sine x. So once again, look for which side is the dumpster fire. In this case, it really isn't going to matter, because if you manipulate the left side into terms of sine and cosine, eventually you can get this. But I'm going to manipulate the right-hand side in this case. So what I see is I'm going to multiply by the conjugate. So I'm going to have cosine x over 1 minus sine x, and to multiply by the conjugate, I'm going to multiply by 1 plus sine x over 1 plus sine x. Come on. There we go. Okay, so in the top, that's going to leave us with cosine x, 1 plus sine x. And in the bottom, I'm going to go ahead and multiply out the denominator. So you can do a double distribution or FOIL, however you want to call it. So I'm going to skip a few steps. So that's going to be 1 minus sine squared x. And then when you get there, so we're going to have cosine x, 1 plus sine x, and then 1 minus sine squared x, that's going to be part of Big Papa, which is going to turn into cosine squared x. And then notice how we have a cosine x over cosine squared x, so I'm going to take 1 away from both the top and the bottom. So when I do that, that's going to leave me with 1 plus sine x over cosine x, which it matches. Wait, no, it doesn't. Hello? I think I'm hallucinating. It's fine. Identities make me go cross-eyed after a while. Okay, so I need it to look like secant x plus tangent x. So yes, it's simplified, but there's still some more I can do. So when I get to this point, when you're like, I don't even know what else I can do. So I'm going to separate the numerator. So I'm going to do 1 over cosine x and then sine x over cosine x. So doing this, so I'm going to have 1 over cosine x plus sine x over cosine x. So 1 over cosine, that is secant x, and then sine x plus cosine x, that is tangent. So secant x plus tangent x. Ta-da! Check. Don't we love it just when things just work? It's amazing. Next. So number 15. Oh, Lordy. Let's do a dark blue. I'm feeling a dark blue. So I look at this one and I see a dumpster fire happening over here on the left side. So, well, let's do the left side. So I can recognize that secant squared n minus 1, that is actually going to be a Pythagorean identity. So secant squared n minus 1 is, drumroll, tangent squared n. And that's going to be over secant squared n. Okay, and then we want it to equal sine squared theta. Nope, looking at the wrong problem. Sine squared n. So now I'm going to change tangent squared n and secant squared n to I'm having the worst actual time trying to talk. I'm getting tongue-tied, y'all. Okay, so tangent squared n is going to turn into sine squared n over cosine squared n. And then that's going to be all over secant squared n, which is the same as 1 over cosine squared n. Okay, so the next thing, I'm dividing by a fraction, so I'm going to multiply by the reciprocal. So I'm going to have sine squared n over cosine squared n times cosine squared n over 1. Ooh, y'all, I'm starting to go cross-eyed again. So we have our cosine squared n's in the top and bottom, so those are going to simplify. So we're left with sine squared n. Which, does that match the right side? Absolutely. Ta-da. Yay. One more. We'll do black like my soul. I'm just kidding, I already have black. We'll do blue. So now we have cotangent n squared, nope, cotangent squared n over 1 plus cosecant n equals 1 minus sine n over sine n. So with this one, once again, both sides are kind of a dumpster fire, so it doesn't really matter which one you do. I'm going to personally do the left side, just because I see more than one term in the denominator, and that means I can multiply by the conjugate, which is another kind of funky form of 1. So I'm going to do cotangent squared n over 1 plus cosecant n, and then I'm going to multiply 1 minus cosecant n over 1 minus cosecant n. Then once again, we're going to leave the right-hand side alone, no touchy. So now I'm going to multiply out the bottom. So the top, I'm going to leave it as cotangent squared n times 1 minus cosecant n. And then when I multiply out the bottom, we're going to have 1 minus cosecant squared n equals. Okay, now in the bottom, this is actually going to be a variation of an identity. So I'm going to go scroll back to the top, and we're going to use the 1 plus cotangent squared x plus cosecant squared x identity. So down here, I'm going to rewrite, just kind of show you. So we're going to do 1 plus cotangent. We're going to go ahead and just do n, just to be consistent with the problem we're doing. So I want a side to equal 1 minus cosecant squared n so that I can replace it with that variation of the identity. So I need to move over the cosecant squared n. So when I do this, we're going to have 1 plus cotangent squared n minus cosecant squared n equals 0. And then I'm going to subtract over the cotangent squared theta, or n. So doing this, we're going to have 1 minus cosecant squared n equals a negative cotangent squared n. So this is a really good problem, just because this requires even a variation of a variation. So the 1 minus cosecant squared n, I'm going to replace with a negative cotangent squared n. So over here, so I'm going to rewrite it as cotangent squared n, 1 minus cosecant n, and then that's going to be replaced with a negative cotangent squared n. So then what's going to happen, my cotangents here are going to simplify, but I still have this negative here. So what's going to happen is I'm going to have negative parentheses 1 minus cosecant of n. Now I want it to look like 1 minus sine n over sine n. So that tells me I need to change that cosecant. But first I'm going to go ahead and just distribute. So this, when you distribute, is going to turn to cosecant, positive cosecant n minus 1. So I went ahead and just kind of flipped the order. So I put the cosecant first, and then the 1 went on the other side, and then I distributed the negative. So that's kind of a 2 steps in 1 kind of thing. Now I'm going to change this to terms of sine. So 1 over sine n minus 1. Oh no, we're not writing 0. That was a mistake on my part. All right, now we need a common denominator, so I'm going to have 1 over sine n minus 1, and then common denominator means I need sine n over sine n equals. So then this is going to be 1 over sine n minus sine n over sine n, and now that we have common denominator equals, now I'm going to do 1 minus sine in over sine in, which it matches. Ta-da! All right, please stop crying. It's finally over. So have fun. Good luck. Love you all. Good luck studying. Make good choices. I believe in you. Yeah. Bye-bye.